Hello everyone, welcome to CodeChef. Myself Joras, and today we are going to solve the problem which came to Starter 223. The name of the problem is CoolTrip and the problem code is CoolTrip. The difficulty rating of the problem is Cakewalk and the prerequisite is at all. Let's start with reading the problem statement over here. So guys, problem says there are n students in a school and x of them have said they want to go on the school trip. The school buses can each carry k people and every bus that is sent to the school trip must be completely full of students. No partially full buses are allowed, hence the number of students going on the trip must be divisible by k. There are sufficient number of school buses. As a teacher, you can convince some students to change their mind, that is either they did not want to go and now they do, or vice versa. You want to change the minimum number of students' mind so that you can have successful school trips. What is the minimum number? It is allowed to do it. No student goes to the school trip. The input format, the first line of input will contain a single digit treated with the number of test cases. The first and only line of each test case contains three integers n, x, and k. Output format for each test case, output on a new line, the minimum number of students whose mind needs to be changed. Constraint for t lies from 1 to 100, x and n lies from 1 to 100, k lies from 1 to 100. So guys, now let's understand the sample test in the question more precisely over here. So guys, this question is very straightforward. It says, uh, there are n students in a school and x of them have said they want to go on a school trip, okay, and the school bus can carry each school bus can carry k people out of this x, okay. So and every bus that is sent to the school trip must be completely full of students. No partial buses are allowed, and the number of students going on the trip must be divisible by k, that is the bus should be full, right? So there are sufficient number of school buses, right? So as their teacher, you can convince some students to change their mind, that is initially they did not want to go and now they do, or either they don't want to or now they either they want to and now they don't want to, basically vice versa. And you want to change the minimum number of students mind so that you can have a successful school trip. So we have to find what is the minimum number. So it is allowed that no students also go to the trip, right? Now let's take the first test. Okay, so so we have got n, x, and k, which is 5, 4, and 2 in the first. So with two buses there are total x, right? And every bus can accommodate two, right? So we can say that with how many buses? So with two buses, every one of can go, right? So basically, uh, so zero minimum changes we need. So output is simply zero, right? Simple, guys. Now let me take one more test case for you. Okay. Let me take 5, 5, and 3. So we need to convince. So basically, it is n, x, and k. So we need to convince two people to not to go, and then the other three people remaining, if not to go out of this two, so other three people can go, right? So how many people, minimum number of people we need to convince so that it's a successful trip? It is two. So output is simply two. Guys, I think the test cases are very much clear and straightforward. Now let's move towards the simple solution. Suppose y students go to the trip in the end. Note that y must be a multiple of k. Since there are initially x students going on the trip, the number of students who need to be convinced to change their mind is then modulo of x minus k. That is absolute value of x minus k. So an initial solution is to simply iterate through all possible valid choices of y. That is y equal to 0, comma k, comma 2k, and compute the minimum possible value of absolute value of x minus y, which will be the answer. The work in O of n time, which is fast enough for the given constant and already enough to get AC. It's possible further to optimize the above solution. Observe that the optimal choice for y will be the closest multiple of k to x. That is, let m be the largest integer such that m times of k is lesser than equal to x. Then either y equal to m times of k or y equal to m plus 1 times of k will be optimal. Computing m is easy enough. We simply have m equal to floor value of x by k. Once m is known, check with both y equal to m times of k and y equal to m plus 1 times of k. Note that y equal to m plus 1 times of k must be checked only if it is lesser than equal to n. This gives us a solution in constant time. To further simplify implementation, it can be seen that we don't even need to explicitly know the values of m. Instead, observe that x minus m times of k equal to x and modulo k, that is the remainder when x is divided by k. Similarly, m plus 1 times of k minus x equal to k minus x modulo k. And so knowing x modulo k alone is enough to solve the problem. So guys, I think the solution is pretty much clear. Now let's move towards the simple C++ code. So guys, this is my simple C++ code. I took the input for all the test cases as well as NXK. I initialize answer equal to x modulo k. I'm checking for the if condition, the last simply printing my answer. And as the you can see that I have got my C++ code as right. Now let's move toward my Python code. So guys, this is my similar Python code. I took the input for all the test cases as well as nxk. I initialize answer equal to x modulo k. I'm checking for the if condition at the last simply printing my answer. And as you can see that guys, I have got my Python code as well as right. So guys, I think the solution, the code and the approach is pretty much clear. Now let's meet in the next video. Thank you so much guys for watching our video.